This is the cost matrix and these are the cost values. We have to transport the goods from three sources to 4 destinations. These are the supplies: 1, 250, 450, 500. Demands: for destination number 1, 200; for destination number 2, 400; for 3, 300; for 4, 300. Now total of the demand is 1200 and the total of available supply is 1200, so that this is the balance problem. Now after this first step, in second step we will be using this northwest corner method. Now in this method, as name suggests, northwest, this is the west side, this is the north side, so that we have to first of all allocate the cell which is at northwest corner. Now this is the cell, northwest corner cell. Now first of all fulfill the demand or supply as per the case. Now for the first one, first row and first column, we will see 200 is the demand and 250 is the supply. So that first of all allocate the maximum demand, that is 200 can be allocated here out of supply of 250. So that just write down 200 here. Now this is exhausted. Now after 200, just subtract it from 250. This will be 50. Now again go for the northwest corner. Now this is deleted. This corner is deleted. Now we have this one. So that this will be the northwest corner. Now for this cell we can allocate maximum 50 units. So that just allocate the 50 units. This will become 0. Now this will become 50. Okay. Now after allocation of 50 units, this will be 350. Now this is exhausted. First row is exhausted. So that just delete the first row. Yes. Now see, this is also deleted and this column is also deleted. Now we have to see the northwest corner. This is the northwest corner again. Just put a square mark and see how much we can allocate for this cell. We can allocate maximum 350 units here. So that just allocate it 350. This will become 0. Now this will be after 350, that means 450 minus 350, this will be 100. Just delete the second column because this is already covered. This is also covered, this is covered, this is also covered. Now we have 2 columns and 2 rows. Just select this one, the northwest cell, this one. Here we can allocate maximum 100 units. Just put 100 here. Now this will be 0. Now after 100 unit allocation, 300 minus 100, this will be 200. Okay. Now this is exhausted. Just delete it. This is also covered now. Now we have these 2 cells, here 200 and here 500. Now just select the northwest here. This is the northwest corner. We can allocate maximum 200 units here. Just put 200 here, 200, and this will be deleted because after allocation there will be no further allocations. This is also deleted. Now after 200 allocations, that means 500 minus 200, this will be 300. Now the last allocation, we have only one cell. This becomes 0, so that this we have deleted. After allocations, if one cell or column being exhausted, that should be deleted. Now we have the last allocation is here, 300. Okay, now this is also, this becomes 0 and this becomes also 0, so that we have 1 2 3 4 5 6 allocations. Now we will find the initial feasible solution. After allocations, we have to find the initial basic feasible solution. Now from this matrix of transportation cost, we can see that we can find the optimum cost of transportation by the equation like 200 into 4 plus 150 into 2. 2 is the unit cost of transportation and 50 is the allocation of demand. Here also 4 is the unit cost of transportation and 200 is the allocation of demand, maximum demand possible. Now to find the optimum cost, it is 200 into 4 plus 50 into 2 plus 350 into 7 plus 100 into 5 plus 200 into 3 plus 300 into 1, that we will see. That we found from the method of northwest corner method. Now while using the least cost method, that is LCM method, in the transportation cost matrix, identify the least cost and do the allocations of demand and supply as per the case. Now in this matrix, the least cost is 1, yes, so that we can start allocation from this cell. Here I can allocate, see the minimum demand that can be fulfilled. Here 300 can be fulfilled, so that allocate 300 here, 300. This will become 0. Now 500 minus 300 will be 200. Now this is the column 4th is exhausted, just delete it. Now see the next minimum cost. Now the next minimum cost is 2. So start the allocation from this cell. 400 is the demand and supply is 250, so that I can give maximum 250 here to the destination second. Now after this allocation, this will become 0. Okay, this cell is also exhausted. Now 400 minus 250, this will be how much? 150. Okay, now this is also covered. The first row is exhausted, 4th column is exhausted. Now we are having 1 2 3 columns and 2 rows. Now in this find the least cost. 3 is also here and 3 is also here, so that I can take the maximum allocation I can give here. I can take these 3. Now for this one I can allocate maximum 200, so that I will just allocate 200 here. This will become 0. This will be 450 minus 200. This will become 250. Okay. Now this is exhausted, so that just delete the first column. Now see, we are having 4 cells. Out of 4 cells, which one is the least one? Yes, these 3. I can allocate units here also. Now I can allocate maximum units here, 200. Yes, 200. This will become 100. This will be exhausted. Okay, this will become 0. Now I am having only 2 cells, this one and this one, so that the list is 5. Now I can allocate maximum 100. This will become 0. This is also exhausted. Now we are having only 1 cell. After this allocation, this will be 250 minus 100 it is. This will be 150. This will be 150. Now the last allocation, we are having only 1 cell with 7 as a unit cost. So that just allocate 150 units here, 150. This will become 0, exhausted, and this will also become 0. Now we have covered all the cells of the matrix. Now the next step is to find the initial feasible solution. Initial feasible solution is also known as optimum cost of transportation. Now from the matrix I can see that there are 1, 2, 3, 4, 5, 6 allocations are there, so that I can start from the first one, that is 200 multiplied by 3 plus 250 into 2 plus 150 into 7 plus 100 into 5 plus 200, this one, into 3 plus 300 into 1. Now we will see the total. From LCM we are having 6 allocations. Now the initial feasible solution will be this one. After calculation we found that rupees 3,550 will be the transportation cost from the method LCM. Now we will see how to solve the transportation problem by using VAM method, known as Vogel's approximation method. Now this is the transportation cost matrix. These are the supply figures: 250, 450, 500, total is 1200. These are the demand figures: 200, 400, 300 and 300, total is 1200. So this one is the balance problem. This is the balance problem. Now in case of VAM method, first of all we have to find the row difference. That means this is known as row penalty, and the column difference, also known as column penalty. Now starting with the first row. See the smallest number. Smallest number here is 2, and the next number to the smallest number is 3. So that just do the subtraction. 3 minus 2, this will be 1. 1 will be the penalty for first row. Second row, smallest is 3, next number is 5. So that 5 minus 3, it is 2. Smallest in third row is 1. Next number to the smallest one is 3. 3 minus 1, 2. Now for the column difference or column penalty, see the smallest number in column 1, it is 3. Next number is 4, so that 4 minus 3, it is 1. Second column, smallest is 2. Next is 4. 4 minus 2, 2. Third column, smallest number is 3. Next number is 5 minus 3, 2. Fourth column, smallest is 1. Next is 3. So that 3 minus 1, 2. Now after getting the penalties, that means the row difference and the column difference, select the penalty with highest number or the largest penalty. Now in this case 2, 2, 2, 2, 2 are here, so that select the number where we can allocate maximum units. Now suppose if we select these two for allocations, see the second row, smallest transportation cost is 3. For this sale I can allocate 200 here out of 450. Okay. For the third row, smallest is 1. Smallest transportation cost is 1. Where I can allocate 300 out of 500. Okay, this is more than the first one. Now for the fourth column, see here also, yes, same thing. This also we can select this also or this also. See this column, third column, here 300. Yes, this can be also one of the possibility. For second column, smallest cost of transportation is 2. 250 can be allocated. Okay. Now we can start with the allocations of the third row. This like this. Select the cell with smallest transportation cost 1. Now how much we can allocate for this? We can allocate at the most 300 out of 500. So that just allocate it 300. This will become 0. This will be 0. 500 minus 300, this will be 200. Okay. Now one allocation has been done. The fourth column is deleted. Fourth column is deleted. Now again find the row penalty and column penalty for the remaining cells. Now for the first row, smallest is 2 and the next number is 4. So the 4 minus 2, this will be 2. For the second row, smallest number is 3. Next number is 5. So that 5 minus 3, this will be 2. For the third row, smallest number is 3 and the next number is 4. 4 minus 3, this will be 1. For the first column, smallest number is 3, next number is 4. So 4 minus 3, 1. For the second column, smallest number is 2 and the next number is 4. So 4 minus 2, this will be 2. For the third column, smallest is 3, next is 5, 5 minus 3, this will be 2, and this is deleted, so that there will be no penalty. Now select the cell where we can allocate maximum units. For this first row, this cell, we can allocate maximum 250 units here. Okay. For second row, this cell, we can allocate maximum 200 units here. Now the next maximum penalty is 2 is also here, so that see second column, it's the smallest transportation cost, this cell, here we can allocate 250 to 400. For this one, here we can allocate at the most 200, so that we will select this second column for allocations. Now locate the smallest cost here. Yes, this is the smallest cost. How much I can allocate here? I can allocate 250. This will be deleted. This will become 0. Now 400 minus 250 is 150. Okay. This first row is exhausted. Now the first row is deleted and the fourth column is also deleted. Again find the penalties. Second row, smallest number 3, next number is 5. Okay, 5 minus 3, this will be. Now after allocations, we can see that first row is deleted and fourth column is deleted. Again find the row penalty and column penalty. First one is deleted, so that just delete this. For the second row, smallest number is 3, next number is 5, 5 minus 3, this will be 2. For the third row, smallest number is 3, next number is 4, 4 minus 3, 1. Now go to the first column, smallest number is 3, next number is 9, so that the first row is deleted. We will see only the second row and the third row. 9 minus 3, 6. Second column, 7 minus 4, this will be 3. Third column, 5 minus 3, 2. This is deleted. Now see the largest penalty. Yes, largest one is 6. Just allocate the units to the smallest transportation cost. Now for this first column, 3 is the smallest transportation cost. Now for this cell, we can allocate maximum 200 units out of 400. So that just allocate 200 here. This will become 0. So that now this is deleted. This one is deleted. Now 450 minus 200. This will be 250. Now the first column is deleted. First row is deleted. Fourth column is also deleted. We have left with only these 4 cells. Again find the penalties here. For the second row, 7 5, 7 minus 5 is 2. there will be no allocation here. Second column, 7 minus 4, 3, 5 minus 3, 2. This is deleted. Now see the maximum penalty. This one, 3 is the largest value. In second column, find the smallest transportation cost. 4 is the smallest transportation cost per unit. Now for this sale I can allocate maximum 150 is here, 200 is here, so that I can allocate maximum 150. This will become 0. Now this is also deleted. Now after 150 this will become 200 minus 150, this will become 50. Now we have left with only two cells, this one and this one. Again find the penalties. For this one, see 5. For the third column, 3. Now this is already deleted, so that there will be no allocation here. First column, second column, no allocation. Third column, 5 minus 3, this will be 2. Now see here, this is already deleted. Fourth column is deleted. Now see, 5 is the largest penalty. Select 5 here. Now we have to do the allocations. 300 is here and 250 is the supply, so that minimum value is 250, so that I will just allocate 250 here. This will become 0. This is also now deleted. After 250 allocations, out of 300 we are left with only 50 units. Now only one cell is there, so that just allocate the remaining units to that cell. This is 50, this will become 0, and this 50, this will become 0. Now all the allocations have been done. Total we have 1, 2, 3, 4, 5, 6 allocations. Now we have to cross check whether the initial solution is feasible or not. Check. N means number of allocations is equal to m plus n minus 1. M means number of rows and n is number of columns. Now we will see here 3 plus columns are 4 minus 1. The answer is 6. So that, and number of allocations 1, 2, 3, 4, 5, 6. Yes. Now we can confidently say that there is no issue of degeneracy. This solution is the final solution. Now just find the transportation cost. Now from the transportation cost matrix and corresponding allocations, we can find the final transportation cost. This will be 250. See the first row, 250 into 2 plus 200 into 3 plus 250 into 5 plus 150 into 4 plus 50 into 3 plus 300 into 1. Now after calculations, we found that rupees 3,400 is the final cost of transportation.